We're on 3A.8, natural logarithms, expressions, and equations. Please disregard how plain and blank your notes are. It's just how I feel. Also, no, I'm playing. I just didn't have time to finish making them pretty, so they're just going to be this, okay? But these are going to go on page 102 in your handy dandy notebook. So, in case you're wondering, or you need to write the number on there where you're going to place it, this is page 102. Our essential understanding, our objective for the day is that we understand that the functions y equals e to the x and y equals natural log of x are inverse functions, okay? Just before this, we've talked about a equals e to the b, then therefore b equals natural log of a. So what the conclusion here is, when I need to quote unquote cancel out an exponent with a base e, I have to take the natural log of it. It's going to eliminate, and whatever the power is left by itself, okay? If I need to take out a natural log, I need to raise it to the e. So it becomes e power of natural log. And again, inverse operations, they're going to cancel each other out. And whatever the argument is becomes the solution, okay? And so that's what we're going to be practicing and emphasizing on, all right? So let's dive in. So part A is just simplifying. So part A is just a quick little review from our previous sections on simplifying. When you're simplifying logs, you want to always start with the power property. So the power property is the one that tells us that a coefficient of a log can become the power of the argument, and vice versa. The power of the argument can become the coefficient of the log. Then we're going to use either quotient property or product property of logs. Remember, quotient property is if you're subtracting two logs of the same base, then you can divide their arguments. Product property is if you are adding two logs of the same base, then you can multiply their arguments, correct? All right, so review of that knowledge that we already should have. So for example, here we have 2 natural log of 2 plus 6 natural log of 1. The first thing we're going to do is apply the power property. So I'm taking my coefficient, and it's becoming the power of my argument. Your notes are for Monday. You should have them. So, okay, so now this looks like natural log of 2 squared plus natural log of y to the 6. Cool. All right, next you're going to determine whether you have product or quotient property of log to use. So you're deciding whether it's a plus or minus situation. If it's plus, then you have product. If it's minus, then you have quotient. Ringing a bell? Okay. So therefore, we have what here? We have product. So that means I can turn this into one log by multiplying these two. As I multiply, I'm going to simplify. What is 2 squared? 4. And y to the 6, can't do anything with. So therefore, this is my simplified natural log for y times 6. Okay, I'm going to give you 30 seconds to do number 2 and go. Right next to on the plus or minus product quotient. I just reiterated the steps that are written above, Austin. You have the steps written down on the paper. All right, let's talk about number 2. So on number 2, again, follow the first step, which is to apply the power property. So your coefficient becomes a power. Your coefficient becomes a power. So we are left with natural log of c to the third minus natural log of y to the third. Second step is to decide, are you product or quotient? And because we're subtracting, then we are quotient. So that gives us c to the third divided by y to the third. And the third step is to simplify. Is there anything in common that I can do here? Nope. So then this is my complete answer. Okay, you remember basic simplifying? Yeah? Okay, let's take it up a notch. So let's look at example number 3. Ignore that mine says example number 1 on here. It was PowerPoint. Ignore this. This is your 3 and your 4. Okay. So example number 3, I have multiple things happening here. Before I can do anything, I need to get rid of parentheses. So I'm going to distribute and get rid of parentheses. Does that make sense? So we're going to distribute the half. So we have 3 natural log of A minus 1/2 natural log of B minus 1/2. I don't know why I made that one so giant. Minimize it. Minus 1/2 of natural log of C. All right. After we've done that, now we're going to go through our steps. So step 1 is the power property. So your coefficients become the power of your arguments, correct? So we're going to become, so 3/2. And yes.
Why did the plus turn into a minus in the parentheses?
Because negative 1/2 times 1 is negative 1/2.
Oh.
You're distributing a negative half. Good question. Okay, so we're left with natural log of A to the 3rd minus natural log of B 1/2 minus natural log of C to the 1. Why did I write C to the 1? There we go. 1/2 times 2 is 1. Okay, to turn this into one log, we go from left to right and describe what's taking place. So we have natural log of A to the 3rd minus natural log of B to the 1/2. What's happening here? We're going to divide. So we have A to the 3rd divided by B to the 1/2 minus C. So also I'm dividing the C. So A was the only thing that was in the numerator, and then B and C are being divided. Okay, number 4. Again, this time we are applying the power property, but in reverse. So our power is becoming our coefficient. So we have 3 natural log of E, which just simply means the answer is what? 3. Because anytime natural log and E are next to each other, they do what? Quote unquote, cancel each other out. So that upside down 3 that I created is the answer. And I don't know how I wrote it upside down. So we're just going to roll with it. All right. How do you feel about part A? Questions, comments, concerns? Okay. Part A should have felt like a review because we have learned and did this before. Got it?